data mining, machine learning, big data, AI. You hear these words thrown around all the time, right? But what do they actually mean? Well, today we're going to cut through all that noise. We're going to demystify the jargon and show you how these kind of futuristic ideas are already shaping your world every single day. So let's pull back the curtain and see how this all really works.
To get started, I want you to picture something with me. Something straight out of a sci-fi movie. Imagine for a second a machine that could actually see the future. Or, at least a little piece of it. I mean, can a machine really predict crimes before they even happen? It sounds like pure fantasy, doesn't it? But the surprising thing is, the basic idea behind it, well, it's already here. If you've ever seen the show Person of Interest, you know exactly what I'm talking about. In it, this reclusive computer genius, Harold Finch, builds a secret AI for the government. He calls it the machine. And its whole purpose is to predict violent crimes by looking at, well, everything. All the surveillance footage, phone calls, emails, bank records, basically all the digital footprints we leave behind. And how it works is pretty fascinating. The machine just takes in all of this data, just a chaotic mess of information. Its algorithm then sifts through that chaos to find these tiny, hidden patterns that no human could ever spot. Now, here's the key part. It doesn't explain why a crime is going to happen. It just predicts who will be involved by spitting out a social security number. It's all about prediction, not explanation. Remember that. Now, that might sound like some slick Hollywood magic, but the real concept behind the machine has a very real and very powerful name. And that name is data mining. What the machine does in the show is pretty much the textbook definition. It's the real-world process of using algorithms to hunt for those hidden patterns and connections in massive piles of data to predict what's probably going to happen next. And this is where it gets really different from something like traditional statistics. See, with statistics, you usually start with a theory, a hypothesis, and then you use data to prove or disprove it. You want to explain why something is happening. But data mining, it flips that script. It starts with just the data and asks, okay, what interesting, unexpected secrets are hiding in here that we don't even know to look for? It's all about exploration and discovery. So this isn't just about fictional supercomputers and academic theories. Data mining is quietly working behind the scenes in so many things you use every single day. Let's take Netflix. Every single time you watch a show, pause it, rewind, or give it a thumbs up, you're feeding data into its system. It mines all that behavior to predict what you'll want to binge watch next. But it goes even deeper. They analyze massive trends from everyone to decide what new shows to even make. That's how they can pour millions of dollars into a new series, feeling pretty confident it's gonna be a hit before a single scene is even shot. Or think about Amazon. It doesn't just know what you bought last week, it's constantly trying to predict what you're gonna buy next week. You know those customers also bought recommendations? Pure data mining. And when they predict a whole neighborhood is about to start buying something, they can pre-stock it in a nearby warehouse to get it to you faster. That's data mining running a massive global supply chain. And it's pretty much everywhere else, too. Airlines use it to change ticket prices based on demand. Banks use it to figure out if someone is a good candidate for a loan almost instantly. And in healthcare, this is amazing. It's being used to predict patient outcomes and suggest treatments by finding patterns from thousands of similar cases. Okay, so we've got a handle on data mining, but where does it fit into that even bigger, broader world of artificial intelligence? The easiest way to think about it is like one of those Russian nesting dolls. The biggest doll on the outside is artificial intelligence, or AI. That's the whole grand idea, born way back in the 50s, of making machines that can think like humans. Then you open it up, and inside you find machine learning, which really took off in the 80s. This is a specific way to do AI where you let the machine learn from data instead of programming every single rule. And inside that, you have an even more specific field called deep learning, which is behind things like facial recognition. So to put it simply, machine learning is the engine. It's the how. It gives us the powerful algorithms that actually go out and find the patterns. Data mining is the process. It's what you're doing when you point that engine at a giant pile of data to make a prediction. You just can't have one without the other. But of course, an engine, no matter how powerful, is useless without fuel. And for the machine learning engine, that fuel has a very specific name. Big data. And it's not just a lot of data. It's this constant, overwhelming flood of information. Some of it neat and organized, a lot of it messy and unstructured, that hits businesses every single day. The really important thing isn't just its size, it's what you can do with it. It's the raw material for finding all those game-changing patterns. Now, to really get what makes data big, we talk about the 5 Vs. First up is volume. We're talking just an insane amount of data. Then there's velocity, the crazy speed at which it's all flowing in, like constantly. Then variety. It's not just numbers in a spreadsheet, it's video, social media posts, audio files, you name it. Then you have variability. The flow isn't always steady. You can have these huge, unpredictable spikes. And finally, and this one is so crucial, you have veracity, which is all about the quality and trustworthiness of the data. Because without that, the other 4 Vs don't mean a thing. Okay, having the power to sift through all this personal information to predict what people will do, well, that comes with a huge amount of responsibility. This isn't just a tech problem, it is a deeply human and ethical one. And there are 3 core principles that should really act as guardrails here. First is respect for persons. You have to treat people like people and respect their privacy and choices. Second is beneficence. The whole point should be to maximize the good that comes from this and actively try to minimize any harm. And third, justice. You have to make sure that the benefits and risks are distributed fairly. So, in the real world, this leads to incredibly important things like data de-identification. And this is way more than just deleting someone's name. It's a really careful process of removing or changing any information that could possibly be used to trace data back to a specific person. It's all about protecting privacy while still being able to do valuable research. This quote really gets to the very heart of the whole thing. We are surrounded by a chaos of data every day. But if we can find the patterns, the order hidden within that chaos, then we can find new ways to succeed and solve problems we never could before. Which leaves us with one last massive question. This technology gives us a power to predict the future that is, frankly, unprecedented. But with that power comes a choice. So the question for all of us is, who gets to decide how we use it? Who decides not just what future we want to predict, but what future we want to create?